Okay, that should be better. Some of these little things that are hard to see on the screen are impossible to see on that thing. And I haven't contacted IT about it yet because I know they have a billion things they're working on. So anyhow, you see those little circles and things I'm talking about? So I could do a lot of different things to clear them, but I'm going to click on this week 1 overview and mark is done. Now I could go back to the modules display and find all of the others that needed something, or I can just click next to go through everything that's in that module. Remember there were like 3 PowerPoints, so I'm just going to click next. And of course, this is a good way for you to go through a module and make sure that you've gotten all of the important things done. We'll come back and look at this reorder the pseudocode here in just a minute. I am not connected to Office 365, so it's upset with me. And then finally, the summary has to be marked as done also. So now if I look at the module, I should see my week 1 now shows this happy green check mark up here that I've completed all of the items that were required in module 1. Now these things can really get frustrating to you, especially if you're trying to get to something in Canvas and it won't let you. So make sure that as each module starts at, you just kind of click through that next thing, because some of them are set to just make sure you viewed the item. So just looking at it will clear that requirement. Now, why would I do that? Well, there's a couple of reasons. First of all, one time I got to the very end of the semester and this student who had started out really good, and then by the end of the semester, he just wasn't doing anything. I mean, everything he turned in was not really the greatest, and he just wasn't doing a good job at all. And he kind of, at the end, said, he had the book, and he held it up, and he was like, I don't know why we had to buy this book. I never did use it at all. And I thought, oh, no wonder he was doing so much worse, so much worse. So he had never looked at these overview things that tell you what chapters you need to read. And so I was like, oh, geez, I'm going to go ahead and make that to where you have to mark it that you're done, so I know you had to look at it.
Something I wanted to ask real quick. I wasn't able to do any work over the weekend because I didn't have my book. I was pretty busy. Is that okay? Because I was just asking that because everything is due on September 1st.
Right, so you're fine.
Okay, good.
You're fine. Yeah, it's fine. And honestly, we'll usually have things like that set up on Tuesday night that things are due. For the week after this one, I have some stuff set on Wednesday because of Monday being a holiday day. So I did change those due dates on that particular week so that you guys would know exactly when things were due. So sometimes when there's holidays, we'll change, but normally Tuesday night. And yeah, sometimes, you know, this book I think is available online just as a PDF. It's not like a super fancy online textbook, but you can buy it that way. So that's fine. Now, looking at the assignments that we had, the reorder the pseudocode one can be really confusing at first. So before we jump on that, let's take a look at, what did I have open? I had found the perfect place. Oh, I know what it was. I want to go to our week 1 module, and let's take a look at the textbook PowerPoint, the introduction to programming. Now, we're not going to look at each slide that's in this textbook PowerPoint because a lot of it is a duplicate of what we looked at in the kind of updated version. But I want to scroll down to where they're talking about our music purchase program. Because in the PowerPoint we viewed, we just sort of had it thrown at you. And in the textbook, they do a lot more building up to that. So always read that chapter. Now, first of all, here's their overview of that music purchase program. If you remember, we're going to prompt the user for how many songs they want. And however many songs they want, we're going to multiply that number by 99 cents to come up with a price for their song. So our textbook is saying, you don't want to write this as a program yet. You're going to write it as pseudocode. Now, before we get off on our pseudocode too much, I explained last time, we're going to write it in pseudocode for a lot of different reasons. And every one of them is hard for us as programmers because we would always like to just jump into the code. But I could code it just as easy as I could write this pseudocode. True that. But what if your company hasn't decided what programming language you're going to use yet? What if they aren't sure? They're thinking, well, we've always used C++ because it's free, but we've heard now that we can get C# free too, and that it's more helpful to the programmer. Or we've got this new programmer over here that's just saying we should be writing everything in Ruby, so we're going to switch all of our stuff to Ruby because this guy says it's good. So no matter what, we might not know what that programming language is going to be. Those decisions may not have been made yet. So we have to be able to document what we want to happen in our program using something that's not code, like pseudocode. So there's where we've started. Now, in your textbook, they show you this actual program code in some different languages. So they say, here's this program written in Java. You don't need to understand it yet. They're just saying, oh, and here's this program written in C++, in case that's something that you're interested in. And we could write that same program using C# or Python or Ruby or all sorts of different programming languages. So they just want you to realize our pseudocode is going to be language independent. We don't care what programming language we're going to eventually use to write this program, because we're just going to document what it's supposed to do. Okay, so we saw that we're going to use the write statement to prompt the user for input, and then we're going to use a variable to hold their input. We saw some rules about naming variables and how those kinds of things are going to work. How to name them. I'm just kind of jumping around here. But what we didn't see is that sometimes, I'm sorry, I'm just going through this very quickly, and I do want you to take a look at it. Okay, here's where I was going. This is where we're going to be today. When we're using data variables, we saw last time that our data variable has different types. So we have string variables that hold letters and numbers, and we have integer type variables that hold numbers without a decimal place. We have floating point type variables that can hold numbers that have decimal places. So our data type is really important when we're programming and we're setting up variables. All these variables are going to do is hold some information for us, but we need to tell the system what kind of information they're going to hold. So when we're working with pseudocode, we can use the declare statement to do that. So I can say at the beginning of my pseudocode, I'm going to need these three variables to figure out my algorithm. So I'm going to declare them. I'm going to declare variable 1 as a string, variable 2 as an integer, whatever I need. But this is the pseudocode that I'm going to use to do that. Okay, so let me find our awesome song program here. I think they have it again. So of course they don't. Let's just go to ours. So I'm going to open this reorder the pseudocode. If you get this kind of display, you just need to log in to Office 365. So I'm going to click log in. Now, when you're working at home, oops, that was fun. None of you should get that. That's because I am working in student mode. So you can see how rough it is on me if I'm trying to do this student view. So I'm going to have to leave it. And then I shouldn't get rejected. Now, if you need to log in, just use your OTC account and you should have all of the information you need. Now, I've been getting messages about people turning this in. So I know some people are all done with it and some people are confused by it, and that's fine. That's exactly where we should be at this point. So before we stop and spend time on it, let's go look at another thing. Go back to your modules. And in week 2, you should see an assignment that says study group notes. I'd like to get this open so that we can do both things at the same time. Now, your study group notes are nothing fancy. They're simply a Word document. And I placed that Word document in Canvas so that your group can share it. So remember we had to complete all those things up there before let's get to it. So see what it's mad at you about. So go into that. Anybody else have it? If it's grayed out and not letting you get to it, remember that's completing those items in Canvas above that. Let everybody get all them done. Is it letting you get to it? Did everybody get to it okay? All right. That's great. So some people, have you ever noticed, some people are really good at making notes and other people are not so good at it. They might be able to remember everything, but they're not so good at making notes about it. Well, in computer programming and in this field that we're going into, if you can figure out a way to organize the information into notes, you're halfway there because you've organized all of this information you need to learn. So we're going to create a notes document that's shared amongst your study group. So you guys can work together on it. One person might be better at taking notes, another person might be better at organizing everything, you know, making it into an outline form. The third person might be better at finding pictures and other things to enhance and embellish your notes. So I want you to work together on these. Now, your notes are going to be a resource for you that you can use on the unit exams. So to encourage you to really make good notes and to really share time with your study group, I'll let you use those notes as a resource. Now, that means they have to be notes. They're not like screenshots of practice questions from the quizzes or the sample quizzes. They're actual notes, like outline type information in an organized format. So I should never see a screenshot of a question. I should never see a duplicated paragraph, right, of information. We should just see nice, short, sweet, to the point notes to help you remember something that you need. So how can you find those? That's what this whole assignment is about. You don't have to do anything to this assignment. You don't have to turn it in. It's just for your information, for you to find where the shared notes are. So to find them, you're going to go to the people link. And then on the people link, you're going to click up here, CIS120 study groups. Then you're going to expand those groups to find yours. You guys already know which one yours is. And over here on the side, you're going to have one group that doesn't have a lock. That's your group, right? And then you're going to choose visit group homepage. Yours looks just a little different than mine. Now, your study group has this group homepage in Canvas that you guys could use however you want. So if you wanted to, you could set up, you know, discussions and send each other questions and things like that. The part that we're going to use is collaboration at the very end. When you click on that, you should see your shared notes document. Go ahead and open it. Now, it's using Office 365 and it's using Word. Up here where you have this option to edit the document, if you were to edit this in the desktop app, you've just disconnected it from the rest of your study group, right? Because now you've taken it from the cloud and you've put it on your desktop. You're going to update it, change it. When you save it, it's going to overlay whatever was out there. So don't do that. Keep it in the cloud so that it keeps track of all of the information from your entire study group. Now, you might have some sort of formatting you need to do where you want one person to open it on the desktop, get it fixed up, and then update it. But be aware that's going to overwrite anything that anybody else does. Okay, so before we go off anyplace else, questions? Can everybody find their shared document? Are you in it? Everybody's got it? All right. So I'm going to set my alarm here for 10 minutes. In the 10 minutes, I want you to work with your study group and talk about your strengths. Are you a good note taker? Are you a good organizer? Who's going to take notes here in this group? Are you all going to do a little bit, or are you all going to try to put pieces together? Who's going to be the formatter? Are there certain people that are going to be driven crazy if these notes are messy? They should probably take over some formatting. Are there certain people that are just born messy but really good at finding the best information? They should be the ones that take the original notes. So work with your group and decide, how are you going to split this up? Now, when you've got that all decided, bring up that pseudocode. Get that assignment done. Explain to the people in your group that aren't understanding how you were able to complete it or what you think is required. Now, as soon as my alarm goes off, we're going to bring up that pseudocode and look at what the right answer is so everybody knows. But it's going to mean a lot more to you if you work with your group on it firsthand. So I'm going to give you 10 minutes. Yeah. Communicate away.
Hello?
I'm pretty good at taking notes. You know, I can take notes, copy whatever, and I can do it during class. I'll take help.
I can edit it if you want.
You're more than welcome. Maybe if you try to ask, taking notes, so maybe like words that are spelled right, but yeah. Take notes.
Did you figure out? Well, you can put your. I'll make one.
I just want to see if that works. Everything done right.
Because they don't exist.
Yeah.
Yeah, that works.
I didn't like the really
And to your degree, you declare your votes first.
Okay.
So you're just gonna.
You guys are on it. Thanks.
So you also have it.
I think this is saved. I'm just not sure.
Declare episcopal.
I'm like you. I wish the save button would disable if it was already saved, but it doesn't. The new attendance is gonna drive me crazy because of that.
And are these right here USB ports? Is that a
Yeah, I
USB
do.
port?
So you're rearranging.
So they usually work.
Honestly, I don't.
Yeah, we can get rid of the computer.
I'm not copying you. I'm just looking at your numbers.
Yeah.
So you're, I can see,
So I did it first just because I think it's better. Just to go first.
It's okay.
Because if you put in F right here and you don't have to declare it as a then the program isn't recognize. So once you declare it down, it's right, then it will be. Yeah, I'm thinking you're declaring like that, so whatever.
I don't know if that's considered.
It is very confusing.
And then it's just more like, you try to figure out.
Sure. Maybe
there.
Oh.
You could put this first and then you're right. Right there. But I think it looks better right here since you're right after.
There you go. Yeah, so it isn't.
I mean, I think
it's
really trying hard.
I have background in Asia, so just trying to get like an idea of programming before I go to the workforce.
Yeah.
I feel like that.
So I can move my way up.
I think it's a good idea.
That's just my opinion, yeah. And also, again, that's not a good.
Do video production and I'm moving to computer and graphics science, getting a certification.
Media production, that sounds really nice.
It's actually extremely easy.
I think we all learned
Let's see what we got. A few more minutes.
I also want input number. And then I wrote the result.
Okay, let's see. So this is kind of like, where do we start? I've been teaching computers for a long time, and no matter what class I'm teaching, there's always that hard part of getting started, right? Because there's always half the class that's been doing that stuff since they were like 6 months old, and then the other half of the class who's never ever had a chance to do that kind of stuff. One time I taught a class that was an intro to the computers class, and so it was people that had never used a mouse or a keyboard before or anything like that. Well, our culture was changing in the town that I live in, and there were a lot of people that had moved into our community from other countries. And so there were a lot of people whose English was somewhat limited. And so this class that I taught was for the very first time, a lot of people that were from other cultures and other countries. And they had actually, some of them had brought their younger kids as interpreters, if you know how that works, because kids usually end up picking up those languages quicker. And one of the first things that I'd always done in teaching people how to use a mouse and a keyboard is play solitaire, right? Because you have to double click, you have to single click, you drag and drop with cards. I mean, that's a great thing to use for learning how to use a mouse and things like that. Well, it was going along really well, and the people in the back were, I could tell they were really animated. There was a lot of laughing and stuff going on. And I finally was able to work my way all the way back there to see how things were going. And what was happening is the kids were trying to explain to the adults how to play solitaire. They weren't explaining to them how to use the mouse and how to drag and drop or anything. So our starting point had been adjusted. And I didn't realize that based on the class, the people that I had as students, that knowledge of solitaire wasn't already there. So it's no big deal. It's just that starting point was different. So we all have different starting points. So when we look at our pseudocode, you know, there can be confusion and other people are like, oh, well, you would do this, obviously. So that's okay because we're all coming from different places. So I want to put this in the right order. So that means I have these lines of instruction that are out of order. It's just like if I told you how to get to my neighborhood last week and I didn't put the roads in the right order. I had you, you know, turning left when you hadn't gotten to that road yet. The instructions would be no good. That's how this is. The instructions are no good. So what would we have to do first of these things to make this a logical progression of instructions? Yes. So our prompt, perfect. We need our user prompt to come first. Logically, that's what we would want to happen before anything else could happen. Now, once we prompt a user for something, what do we have to do? We saw it in our book, and I said it a lot, but we haven't done it yet. We have to read that the user types in, right? Otherwise, we don't know what they said. And it's pretty rude of us to ask them a question and ignore their answer completely, right? So how do we read what they said? We use input. So I'd make that line next. Now, I could maybe do some of those other things before I read in that C, my Celsius value, but why would I? This prompt is connected to that input, so I'd want to keep them together, right? What could I do next then? Should we do those at the very beginning? Yeah, let's put those at the very top. And it doesn't matter what order we put them in, but a lot of programming languages don't care if we put these declarations at the very top. We can kind of put them wherever we need them, but programmers like to do things neatly and in an organized manner. So we usually keep all of those declarations of variables together and at the top. Now we know when we try to input C, we know what C is. C is a floating point number that could have a decimal place. Much better. Now what do we want? We're getting things lined out here pretty good. We've now declared our variables. We've prompted our user for the Celsius, and we've read in that Celsius value. What could we do next then?
Put in the functions that have equals.
Okay. We have this big old hairy calculation to calculate our Fahrenheit value. So we can do that now because we know what the value of C is. Notice that this formula is dependent on that Celsius value. We couldn't put that up above and get valid results. If we put that above where we read in the value of C for our Celsius, we wouldn't get a valid number out. Okay, and then what do we have left? Our outputs. To us, it doesn't matter what order those are in. We could have had some sort of requirements from our user that might say what order they should be in, but our program is not going to care. We can put those in whatever order we want. So the lines of code that matter as far as order goes, we shouldn't input into a variable unless the variable's been declared. We shouldn't calculate the value of a variable unless the variable's been declared. We can't use a variable in a calculation unless the variable has already been initialized. We know what the value of it is. And then in the same way, we shouldn't write it out unless we know what the value of it is. So does that make sense? Very small pseudocode, just putting it in order. If I try to run it this way, what happens? It's all messed up, right? So first thing I'm going to do is prompt the user. Then I'm going to try to come up with a value of F. I'm going to come up with some value, but it's going to be wrong, right? And as I go through, I'm just not going to be getting the right things at all. So this is kind of like, I want to bake a cake. So I'm going to take the pan and put the pan in the oven and leave it in the oven for 45 minutes. Then I'm going to take it out and mix up the ingredients. Is that cake going to work? No, because I didn't do it in the right order. So when we're writing code, writing a program, we have to have it in the right logical order. It always matters. So get that saved.
Is this trying to figure out Fahrenheit? Basically, it's an equation to figure out Fahrenheit.
Yeah, it's an equation to
So,
figure out Fahrenheit.
Wouldn't it make more sense to have right temperature in degrees Celsius before set F equals in the equation? Because then you know what C is.
It depends on how you want to look at it.
But
And I think that's
could
a
be
very
right.
valid point.
Okay.
Now, for me, you'll see that as we write programs, I'm going to emphasize input, processing, and output. So I'm going to try to keep those things separate.
Okay.
But yes, logically, it might make more sense to you that way. Other questions? Because this is just a little bit of pseudocode, but it has a lot of deeper meaning and thinking about how things have to be in the right order. We have to declare our variables before we can use them. We have to say what data type they are. Great. Now, we're just getting started here. So don't worry. Sometimes with the 120 class, I don't know, it won't happen with you guys, I'm sure. But sometimes I'll have people come to me at like 2 weeks into the class, 2.5 weeks, and they'll just be so upset and they'll say, I'm so confused. I don't know how to write a program. I don't know what I would do to make an app. I want to make an app and I don't know how. Give yourself a chance. That's the same as a brain surgeon coming into the day one of medical school and taking his very first class about washing his hands and going to the professor and saying, Professor, I feel like I am not prepared to do brain surgery yet. What shall I do? Well, you should give yourself a chance to learn, because that's why we have all these different classes. So don't be hard on yourself, especially you guys right now. With the pandemic, a lot of people are getting very hard on themselves, and they're being like, this is my chance. Just relax, you know. Don't get that stressed, because it'll all make sense. In order to make things make sense, we have to know what we're working with, right? So we've got pretty well done with our week 1 stuff. These chapter review questions, remember, once you click submit, they're going to disappear and you're not going to see them again. It's okay. They're very nerve-wracking. That's all right. We'll get used to it. So let's go to week 2. Now, week 2 in our textbook, we're not going to spend a lot of time looking at our textbook for week 2. Chapter 2 is talking about representing data internally within memory. So some of chapter 2 is very, very understandable. Some of it was written for the brain surgeon, right? And it might be a little bit beyond what we're looking at right now. But what chapter 2 is concerned with are those different data types, right? How does the system represent or keep track of these different types of data in memory? How does the computer know that this is a string and this over here is a floating point decimal and this is an integer? It's going to have to keep track of things in a certain way. Whenever computers were first invented, there's actually a couple of different times that people had worked very hard on them. But back in the 40s, when they were really invented in the 1940s, the scientists were figuring out how they could use electrical signals to keep track of data. And they said, you know, it would be really nice if we could use this electricity somehow in a computer, because we all wanted computers, right? Because we all hate math and we wanted something else to do math for us, which is what computers do. So the engineers were like, you know, how could we somehow use this electrical current to keep track of information? We only have 2 states. Electricity is either on or off. How could we use two states, on or off, to keep track of numbers that are in the trillions or you know, petabytes or anything? How could we do that? And they thought, well, we could use a binary numbering system because it only uses 2 numbers. So we're going to look at binary and kind of understand how this information is represented internally in memory. So I want to click on this info binary information. Now there's a video out there just in case you're absent or you want to review. We're going to look at this PowerPoint and this document, the binary numbering system practice. This is the document that I gave you, so you have it. So we should have most everything here. Let's look at that PowerPoint. This PowerPoint was one of the first ones that I did way years and years ago, so sometimes it's a little glitchy. I apologize, but I have not redone it. So let's look at binary. I want to be able to store information in a computer in some sort of memory that is not organic, right? It's only mechanical. So how can I keep track of things like that in mechanical memory? Well, I can go to binary, and I need to look at the basic principles of numbering systems overall to kind of review what binary does. So 3rd grade math, when we use numbering systems, all numbering systems use unique characters or numbers to express a value, and the base of the numbering system defines how many digits we have in the numbering system and the base of our columns. Side note, an exponent is expressed as a power. So if we say 10 superscript 3, all of you all that are in college algebra and all of those really advanced classes can laugh. That's all right. This is getting to the basics. If we say 10 superscript 3, we say 10 to the third power. 10 is the base, 3 is the exponent. And we calculate exponential value by multiplying that base number by itself, exponent number of times. And I want to make sure to review this to make sure, again, that we're all at the same starting point. So if I say 10 superscript 3, that's the same as 10 to the third power, which is exactly the same as 10 times 10 times 10, 3 of them, or 1,000. So our base 10 numbering system that we use all the time uses columnar values. We have the ones column, the tens column, the hundreds column, and each of those columns gets its value by taking the base of our numbering system to a given power. So the rightmost column is to the power of 0. The next is the power of 1, etc. I'm going to write that down all beautiful like that. So if I'm working with base 10, the numbering system we normally use, decimal, we have 10 unique digits, right? 0 through 9, 10 of them because 0 counts. 10 is the base of each of our columns' exponential value, and that's how we get our ones column, our tens column, and our hundreds column, because our ones column is 10 to the power of 0, and any number to the power of 0 equals 1. Then the tens column is 10 to the power of 1, because any number to the power of 1 equals itself. The 100s column is 10 to the power of 2, 1000s is 10 to the power of 3, etc. So we can make a cute little chart like this if we wanted to figure out how much a given number was worth. But we don't have to, because we do this kind of math internally in our heads all the time without even thinking about it, right? Because we use decimal numbering system all the time. So I know in my head, if I have the number 3,486, I'm going to start with the ones column. I have 6 ones, I have 8 tens, I have 4 100s, and 3 1000s. But if I did the math, multiplying it all out, I would be able to add it up in the end and see that that number equals 3,486. Right? Because I'm just representing it using a decimal numbering system. So 3,486 is the same as saying 3 times 10 to the third power, plus 4 times 10 to the second power, plus 8 times 10 to the first power, plus 6 times 10 to the 0 power. Or it's the same as that bottom calculation, 2. So we could express that number in so many different ways. Now, what does that have to do with binary? Well, binary is base 2. So I can only use 2 unique digits to define values, 0 and 1. 2 is the base of each of our columns, because that's now the base of our numbering system. And why this is so handy for working with computers is I have off and on, 0 and 1. So I can keep track of something electronically. So some binary terms that you need to know that you've probably heard before, but you might not know exactly what they meant. One binary digit is a bit. So 1011 is 4 bits. If I have 8 bits together, they're a byte. 4 bits are a nibble. We don't hear that one very much. Half a byte. And leading zeros are insignificant. So this number, 0001, is exactly the same as this number. I just don't have all 8 bits accounted for in that second one. Now, whenever we're working with binary and 2 is the base of our columns, we're going to start out with 2 to the power of 0, which equals 1. So the first column we're going to have in binary is the ones column. The next column over will be 2 to the power of 1, which will be 2, because any number to the power of 1 equals itself. Then 2 to the power of 2, or 4, 2 to the power of 3, or 8. So our columnar value, we'll notice, is going to double each time we move to a more significant column. Now, I need a side here that's really important for you guys' basic understanding to know about how some of these terms got created and how much each thing is worth. A bit or a byte was the very first measurement that engineers came up with when they were developing computers. And they said, you know, that's not very much. We could hold like a letter K in 8 bits, but what if we need a whole sentence? We need a whole bunch of bytes together. And they were like, well, I guess we could say if we had 1,000 bytes, we could call that a kilobyte, right? That would be like 1,000 bytes. And if we had 1,000,000 bytes, we could call that a megabyte. And they just took some of those standard prefixes that already exist for kilo and mega and things like that, and added the byte to the end of it. So we can see that 10 to the power of 1, I can't see it very good. I'm going to look over here. 10 to the power of 0 is 1. 10 to the power of, what do they have? 3 is 1,000. And it shows you that all of the different powers of 10 come out to those values. So they're not exactly the powers of 2, but close for us. Okay, so let's do some conversions. What if I have a number that's been given to me in binary? How do I figure out what that's worth in decimal? I'm going to start by writing down the powers of 2. So I'm going to start with my 2 to the 0 power is 1. 2 to the power of 1 is 2. And as I go across, increasing in value, again, as I work with my different powers of 2, I'm going to see that that decimal number is doubling. Now, the next thing I'm going to do is take my binary number. And in this case, I want to convert the number 10111. And I always want to start with that lowest digit, the least significant digit, my 1th digit, and line those up under my columns. So I would have 1, 1, 1, 0, 1. Now, once I've lined the numbers up under my columnar values with binary, it's super easy. All I have to do is take the value of the columns that have 1s in them and add them up. So I have 16 plus 4 plus 2 plus 1. I have no 8. So 16 plus 4 is 20, plus 2 is 22, plus 1 is 23. So I know that binary 10111 equals decimal 23. I'll show you those when this thing clicks all back where it's supposed to be. Whoops. There it is. So you can see how every column that has a bit turned on, we're going to add up that columnar value. So let's look at another one. 11010. The bits are already lined up for you under the columns. So what would that binary number be equivalent to in decimal? I heard it. 26. Does that sound right? Good to everybody? We have 16 plus 8 plus 2. Perfect. Now, again, we could do that math. We could say, oh, we have 116, we have 18, and we have 12. But since we're working with binary, we can never have more than 1. So we can just add up our columnar value. Okay, what about this one? 100100. What's its decimal equivalent? 36. Does everybody see it? Super easy to convert to decimal. Okay, so on this sheet, I want you to start with this column over here. We have a binary number. We want to convert it to decimal. The columnar values are already written out down here for you. You can write the number down below them to add it up, or you can just look at it to add it up. But I'm just going to give you a couple minutes to work on this column here, convert to decimal. Now remember, when you're taking a certification test, you can't have a calculator or anything with you. So that's why we do this by hand with our heads, because we'll be prepared. Great. Let's do the other half then. Everybody was just flying right through that. Just hang on to it. If you didn't get quite done, that's okay. I'm not going to take them. I'm not going to grade them. They're just for practice. Now we want to go the other direction. And this is a little bit more difficult, but there's a lot of different ways to do it. So I kind of do it just the way that comes easiest to me to remember. And that's kind of the opposite of what we just did. So I'd start again by writing down the powers of 2, all of my columns here, my columnar values. And honestly, you guys, it had been about, a really long time, 15 years or so since I'd done a binary conversion, when I was sitting in a certification test getting ready to teach, and it asked me how to convert what a value was. And I sat there with that question going, I don't remember how to do that. And all I could think was the powers of 2. If I just write down the powers of 2, it's going to start reminding me how to do it. And I was able to remember how to do it. So writing down the powers of 2 is just always a really good way to get started. It's kind of like when you learn how to play the piano, they're always playing those scales. I don't think it's to practice scales, it's to get started. Sometimes we just have to do something to get our mind and our body into the movement. So I write down my powers of 2, and then I take the decimal number that I want to convert. And in this case, I want to convert the number 21. And I start at my highest significant digit. Last time, whoops, I started at my lowest. This time I'm going to start at my highest. In looking at my highest significant digit, I say, does 21 go into 64? No, it doesn't. 64 is too large. I don't have any 21s in 64. Does 21 go into 32? No, it doesn't. It's too large. Or I'm sorry, I should be saying that the opposite direction. Does 32 go into 21? No, it does not. Does 16 go into 21? Yes, it does. It fits. So I would say, I can turn on the 16-bit. So I would put a 1 there. Now, when I put a 1 there, sometimes when I touch it, it does things, but not when I want it to. When I put a 1 there, I know I've accounted for 16, so I'm going to subtract that 16 from my starting number. Now I have 5 left to convert. Does 8 go into 5? No, so I'm going to put a 0 in my 8th column. I still have that 5 to convert. Does 4 go into 5? Yes, so I could turn on my 4-bit and subtract 4 from what I have left to convert, telling me I only have 1 left, so I would know my 2-bit should be 0 and my 1-bit would be 1 or on. Does that make sense? So decimal number 21 is equivalent to the binary number 10101. Now let's try another one. How about 14? What's the first bit I would turn on? I heard it. 8, the 8-bit. If I turn that 8-bit on, that's going to leave 6 left to convert. Sorry. So what's the next bit I would turn on if I have 6 left?
4.
The 4-bit. So I would turn it on. That's going to leave me 2. So what bit would I turn on? The 2-bit. That's going to leave me none. So my 1-bit would end up being 0. Now with binary, there's so many fun things. I mean, it's just like a fun puzzle game. But since this decimal number was even, we know that in the end, our 1-bit should be 0 because it was an even number. How about decimal 36? What's the first bit I would turn on? 32. How much would that leave me left to convert? 4. So I'd fill in with zeros. Until I got to my 4-bit. And then that would leave me none. So I would fill in with zeros. Now those ones can be a little bit harder to do without a calculator. But I mostly gave you pretty small numbers so that it wouldn't be too bad. So it's the process we want not anything else. So let's work on those for just a few minutes. These ones can be a bear. Yes, it's practically the way people in here to them, the binary stuff is just so silly. That's okay. Let's go ahead and I'll show you how you can check yourself, because I so meanly said when we're doing certification exams, we have to do that kind of stuff from memory. But in a normal day-to-day situation, we would be able to use a calculator. I have the Windows calculator open. Go ahead and open up your Windows calculator on the screen. The poor Windows calculator is one of those tools, what do they say, it hadn't been updated since Windows 3.1, and then they updated it for Windows 8.
Wow.
It's amazing. It's still an amazing tool, but it doesn't look that great here, does it? Can you do a binary conversion? You actually can. If you change your view and go to Programmer, now you have these little radio buttons to change the base of your numbering system. So I could say, right now I'm in decimal. Let's do 52, and I could change that to binary, and then it would do that conversion for me. I could go back to decimal. Now notice when you're clicked on binary, you only have ones and zeros that you could use, that you can change that to decimal. So you can double check all of your answers. Now the other two numbering systems that are on the calculator are other numbering systems that programmers use a lot. So we've seen decimal, base 10, and binary, base 2. The other two they have listed, hex, is hexadecimal. It's base 16. So with base 2, you see how just a little number takes up a whole bunch of ones and zeros. Our numbers get really big. We need a lot of memory, a lot of disk space to hold things. But then if we take that base 2 and convert it to base 16, all of a sudden we don't need hardly any memory to hold that big number because we're using a different base. Now, oct stands for octal, which is base 8. Base 8 was used early on by a lot of like Honeywell and some kind of off-breed computer manufacturers, but we don't see it a lot anymore. We still see binary decimal and hexadecimal all the time used in today's systems. So those are important systems. So the computer is going to store everything internally in binary. So lots of work. So we see then, I'm going to go back to our modules. So we see how if we have a number stored in binary in memory, the computer could convert that number to a decimal number and tell us how many songs somebody wanted to buy, or 99 times the number of songs. But what about string data? How do we make a string data like the letter A be binary? Well, because it's not a number, there's not a straight conversion. They came up with this ASCII conversion. So take a look at the ASCII chart that's there in week 2 for you. The first one that it displays, it says it's the ASCII table, and then there's an extended one behind it on the tab. These first values aren't very meaningful to us. You have to scroll down a little bit. But then you'll start seeing some special characters. So if I wanted to store an exclamation point, this would be the binary value that means explanation point. I'm going to scroll on down. If I want to store the uppercase letter A, I would use this binary representation. There is no conversion that I can do. It's just a straight code table. So this code table was developed in the 40s when they were working on computers, and they said, well, geez, if we're going to save everything in binary, off or on, we can store numbers that way. We know how to convert them. We know how to get them back. But how do we store character data? They sat down and they said, we'll encode it. We'll just make a code table. And we'll say the letter A is this, the letter B is this, the letter C is, and that's how simple it is. It's just a code table. Now, if I keep going down the ASCII code table, I'm going to see after the uppercase letters, all the lowercase letters. So all of these character-based pieces of information have an assigned binary value that goes along with them. But how do I know that this vertical bar, 0, 1, 1, 1, 1, 1, 0, 0, how do I know that that in memory means vertical bar and not some number?
Zero.
Sometimes they might actually do that. But if you look at the extended one, you'll see that that went away. So that was a really good way of doing things early on with the original ASCII code table. But then they decided, oh, we have to account for symbols worldwide in the ASCII code table. So it got blown out of proportion because now we have all of the Ganji character set symbols and everything. But you are thinking that is such a good answer. Let's look at the extended one. In the extended one, you'll see we have all these other extra symbols and it goes crazy, and we start using things that start with the letter 1. So the only way we can know is if the programmer tells us. So that's why we have to say what data type our variables are, because then the system knows, oh, if your data type is a floating point decimal, I'm just going to convert this binary value to a number. But oh, if your data type is a string, I need to use this ASCII code table to convert that binary value to what you want to see. And that all happens behind the scenes without us ever really doing anything. But that's why as developers, it's so important for us to specify that data type, because otherwise the system doesn't know how to convert the data that's stored in memory to the data that we want to use in our program. Does that make sense? Kind of a long thing, but I'd like for you to have that foundational understanding of the way binary works. So you don't have to turn this in. This is totally just for you, just for worksheet, just to try it, to see how things work. So that was our 1947 implementation. Let's move up to the 21st century here, and let's look at Scratch. So this is our big assignment for the week. It says week 2 assign, create with Scratch. So this assignment is a discussion board. I'd like for you to use Scratch to create a small game or video, and you're going to post your URL to this discussion board so everybody else in the class can see it. So we have some time, right? We have Wednesday to work on this, because we'll have a lab day Wednesday, pretty much to focus on your Scratch game. And then on Monday, it's Labor Day, so you guys have a 3-day weekend coming up. So it won't be until next Wednesday we'll actually show each other our Scratch game. So we have some time. So what is Scratch? Let's take a look. I'm going to go to the Scratch website here. And to remember the other day we watched that video, that code.org video, and it had the Will.i.am and Bill Gates and all of them talking about, I had a red circle, and they showed the one programming tool that had the little dog that runs around. This is kind of also from MIT, but it's a little bit more advanced than the one that they showed. So Scratch lets us create games and animations and different things like that. But before we can do much, let's go ahead and join. So join Scratch. And it just wants a username and a password. So it says don't use your real name, but do remember what you use. See if I can remember mine. Everybody clicking. We'll only use Scratch for this one assignment, but a lot of people like using it. I've had some former students that like to come back to it kind of if they're having some stressful things going on and create in Scratch because it makes them feel creative and all that fun stuff. Okay, so once you've got your account set up, go ahead and log in, and let's start with Explore. So Explore has a bunch of projects and things for us that we could look at. But what I'd really be interested in when I'm looking at exploring are tutorials. So see how those options are available. I really don't want to see everything. I really just want to see tutorials. Now, once you click on that tutorials button or icon, you should only be seeing games that are some sort of tries to show you how to do it. Be careful, because you know how some people are better at tutorials than others. We don't want to get one that's not too good. So you can load more, and you can kind of keep looking through and finding all sorts of stuff to know how to do things in Scratch. Okay, well, we explored the tutorials. Let's create. I want to create one. So when I go to create, my little environment here is kind of all compressed for me. Here's Scratch the cat. He's my character that's going to move around that I'm working with. I can change it. I can put a different sprite in there or whatever I want, but for right now, it's the Scratch the cat thing. Over here are the tools that I have available to me. Let me make it where you can see the rest of this screen. And all of my tools are these different color-coded icons. So I'd like to do something that just shows how the cat can work. So let's say I'm going to start out with these motion blocks. This is called blocky code. And blocky code is code that is kind of hidden or trapped in these blocks. And as we move them and rearrange them, it rearranges the way our code works, kind of like pseudocode. So this is, again, another way for us to see how sequence matters, and we have to do things in a certain order. So let's start out with the move. I'm going to drag this move block out on my surface here, work surface. And I'm going to change it from 10 steps. Notice how if I click on it, he does that thing. But if I click, if I move until my mouse pointer turns into the bar icon and click, then I can type a different number. So let's say I want him to move 20 steps, and then I can make him move a little further. Now, I'd like for him to go ahead and maybe turn. So I'll say that I want him to turn 90 degrees. So now, every time I click on it, since my blocks are connected, it's doing both actions. He's moving and turning. I could have him take some more steps after he turns, and however I want him to do it. Now I could have him move a whole bunch. You know, I can change the number in that move, or I could add a bunch of blocks down here to make it happen a bunch of different times. So those are our motion blocks. We can move to a certain direction, change our XY coordinates, all those kinds of different things. Let's look at some of these other things over here, these other tools, our code tools. The purple stands for looks. So let's see, I could have him say hello for 20 seconds maybe. Now if I click on this thing, he's gonna say hello finally when he's done. And with your looks kind of thing, you can have him think, and so he's gonna kind of do that little face where he's thinking, all that kind of stuff. The pink then is sounds. So this awful meow sound, let's do it. We'll start that sound, meow. Oh, thank goodness you can't hear it. Let me see why. You should be able to. I'll drag this play sound meow until done. Nope, still not making noise. I've got something turned off. I bet somebody changed it here. If you have headphones on, you'll be able to hear it. And you'll be like, that sound is so annoying. The meow sound is quite annoying. So you could load sounds over here in your control area. You could load backgrounds and all sorts of different things. All right, so I'm going to go past sound. I'm going to go to events, the yellow. Now, notice that they're a little bit different. They kind of have this curved top where they don't necessarily fit into a block. So the first one, when the green flag is clicked, is like a starting point. So it doesn't have a connection on top because it's kind of a starting point. So now that I added this control, I should be able to click this green flag and have it start my whole thing. I could have these other events like when the space key is pressed, when the loudness, all those things. Now the control icons allow us to repeat things. So this one here says repeat. Whoa, there he went. I told you that noise is really annoying, and he does it really randomly. So I could say that I wanted to repeat this whole thing 10 times. Notice how my repeat block will automatically surround all of those different blocks that I have. Now, sensing is going to be asking things like you might have interaction between different sprites going on. You could stop it, ask one what its name is and wait for the response. The green operators are like adding things, doing different events, joining, here they're joining the apple and banana. The orange is variables. So you can tell from looking at Scratch, you don't have to do a lot of declaring of variables. It'll automatically set them up for you. But you might want to change some of their values, so you can do that with the orange. And then the my blocks, you could kind of make your own, so you can make it do all sorts of crazy things. All right, I want to change the background and then leave it to we got something going. Let me get it in the right spot where I can see it all. There it is. So since I kind of cut off a little bit over here, what we're looking for is over here on the very edge, there's the backdrop, the stage. So you can choose one that's already been preloaded, or you could add your own backgrounds. So here, I'll make it a farm. Now my cat's walking around in the farm, saying hello every once in a while, and he'll randomly spit out that awful meow. So there is my Scratch game. Now, really important before I can share it with the rest of the class, it's best to give it a name up here. Mine says Untitled 8. I'm going to name it. Whoa, see? Stop it, you stupid thing. I'll name it like Scratch Test. And now that I've named it, I can share it. When I share it, when I click share, I can copy the link, the URL that it's given, quit it, the URL that it's given, and post that in our discussion board. That's what we want, posted in our discussion board. It should say projects. Now, if you try to click share, notice it's not going to let you share until you validate your email address. So make sure you're looking for the email, because otherwise you can't share your Scratch and get a good URL to share with the rest of us. Now we have about 20 minutes left. Can I make him stop? Please stop. So we have lots of time to get started here and work on this Scratch. When we're in class, especially since we're working with this weird semester, I won't necessarily stop an hour in to give you guys the 50 minutes of lab. If you hadn't noticed that, you probably already picked up on that, haven't you? And that's because I want us to have the majority of our lab time all at once. So on Wednesday is a lab day. Wednesday is a day to work on your scratch game. So you are welcome to do that from home. You're welcome to do that from here, whichever you would rather do. But that's why I've kind of focused all of our stuff in today instead of stopping and giving us lab time. Now, when we get done and we still have 20 minutes, you're always welcome to leave at that point if you want to, or stay and work on your lab stuff in case you have questions or run into some sort of problem. So we have about 20 minutes to work on it today, all of our time Wednesday. So Wednesday, again, totally up to you as to whether you come in or don't come in. So I'll count you as here because we are having a lab day. Okay, so I will start the Zoom session, but I won't be broadcasting anything. So you can just connect if you have a question, if your scratch game isn't doing something that you think it should. Now, one caveat. On Wednesday, when you guys are all working on your scratch game, you're going to get a lot better at helping each other than I am, right? Because you will have all been working with it right now, right in time. So coming Wednesday, you might actually get better help from other students than you would from me. But remember, you've got your study group, so reach out to them if you run into any questions. So any questions before we close out? You're all good? Everybody good? Got everything? Okay. I'll see you next Wednesday if I don't see you Wednesday.